about the OSPF routing protocol configuration. This is the CCNP part. Okay, this is the CCNP part. Is way more advanced than the CCNA. Okay. Alright, this is the topology. We have the shared topology here. That's the Ethernet topology, and I have the point-to-point links here, the two point-to-point links here. Okay, so this I'm going to configure OSPF on each of these routers, and we will configure the route sonorization, and we will tweak the DR selection, that is the designated router selection, and the OSPF cost calculation also. Okay. You will learn a great deal of information here that you will actually find in the CCNP Route certification exams. Okay, without wasting my time, I'm gonna show you the objectives. These are objectives. Okay, we have 6 questions that we need to answer. Okay, the question 1 states, configure OSPF for the above network diagram, the topology that I show you. Route 1 will act as an ASBR. You are supposed to know the meaning of ASBR since CCNA level. Autonomous system boundary router, by redistributing a series of static routes into the OSPF network. Okay, we have the static routes, so the OSPF, the router 1 acting as the ASBR will be redistributing those static routes into the network. These routes should not increment their metric as they pass through the network and should have an initial OSPF cost of 200. Okay, that has to do with the OSPF types. We have route type 1, we have type 2, so you have to know which type increments and which type doesn't increment. Okay, so the E1, the type 1 increments, so the type 2 does not increment. So in this case we are going to use the type 2. Continuous. All routers should have a router ID reflecting their host name. You should be able to ping this router ID throughout the entire OSPF network. Okay, so we better start with this objective 1. Okay, this is, we're gonna start with router 1 here. These are the static routes. Okay, dot 1, dot 0, dot 1, dot 2, dot 3. Those are the static routes. So I'm going straight to the terminal window and start configuring the router 1. Okay, I have my terminals here for cleanup. Okay, router 1. So I'm going to global configuration mode by typing configure terminal. Okay, this is short for configure terminal, conft. Alright, I'm going straight into so IP interface brief. Let me see if the interfaces are been configured already. Okay, our fast Ethernet 00 is being configured, and okay, do so IP route. You're gonna see the routing table. I do type here do because I'm in the global configuration mode. If I'm in the privilege mode, I just type show IP route. Okay, this, you can see the routing table, you can see the static routes, and you can see the connected route. So I will, let me go to the privilege mode and show IP protocol. Okay, we have no protocol configured yet. We have no dynamic protocol configured. So I'm going to the global configuration mode, and I have to reset this so that we can, okay. Then I will show router OSPF. Okay, that's number 1. Okay, router ID, that's the first thing you should do, 1111. Remember, it should reflect the host name. Okay, so network. Which network are we talking about here? We're talking about 712.30.0.0/24. So I will say 712.2.0.0. Okay, that's the wildcard mask. That's been treated in the CCNA level. So area 0, that's the backbone area. Remember, when designing the OSPF topology or network, you can have multi-area network. Make so all the other areas are connected to the area 0, which is the backbone area. Okay, so I have network command and the area 0. Good. Let's go back to the objective. The objective says configure OSPF for the above network diagram. Route 1 will act as an ASB by redistributing a series of state routes into the OSPF network. These routes should not implement their metric as they pass through the network and should have an initial OSPF cost of 200. All routers will have a router ID reflecting their host name. Okay, we go into the redistribution. Redistribution is always different when you are dealing with a BR. This is the area border router. This is the area border router. We still manage this router, so the way we configure redistribution on this or in summary or whatever will be totally different from our configuration on router 1 because it is an ASBR. It is the router that is standing between our network and the outer network. Here you can have RAPE, you can have GRP, you can have BGP. Okay, so but before configuring that, let me go straight and configure all the other routers first with the EIGRP command, with the OSPF command. So I'm going straight to router OSPF1. Okay, router ID, this is 2.2.2.2. It's router 2. Okay, network 172.40.0.2.0.0.0. That's the wildcard mask. Okay, area 0. Okay, remember router 2 is standing in between two areas. Okay, you have one interface on area 0 and another interface on area 10. So I'm gonna go straight and configure this interface here. That's the 000. Okay, so the 000 interface is, what is the network 172.40.10.2. okay, 0.0. That's in area 10. So remember the base configuration is already done. I didn't record that because it would take time. This is for CCNP level, so to configure the host name, to configure the interfaces, the IP address on the interfaces, I've done that without recording them, so to go fast. Okay, so we are done with that. I'm going to router 3, which is router here. It's lying between the area 2, area 20, and area 0. Okay, it's an ASBR, it's an ABR router. Okay, router 3. Configure terminal, router OSPF1, router ID 3.3.3. Okay, and network. Which network are we going to configure? The same network here. Okay, this shared network 172.30.0.3. Okay, wildcard mask all zeros and area 0. Okay, watch out. Yep, Good. And I'm going to configure this network command here, this slash dot 20. Okay, this is, sorry, 20 is going to be network 172.30.20.3 /4 area link. Okay, this is another network where the serial interface belongs to this network, and it's in the area 20. Okay, you know why I put the wildcard mask all zeros? Because it's a specific interface that I'm using here, because that tree. Okay, here this fast interface here is that tree, and here also this serial interface is that tree. So the router 2, all the interfaces are .2, router 1, the interface is .1. Okay, by now we should be seeing some neighbor relationship forming. Okay, you see the OSPF process 1 it's loading to full. Those are the stages of neighbor relationship process. So you have to know the stages that are involved in the neighbor relationship, OSPF neighbor relationship. Okay, it starts. Where does it start? Down state. From down state it goes to init state, or the initial state. From the init state it goes to two-way state, and you have the start state, and you have loading state, and then you have full state. Okay, so now these three routers, 1, 2, 3, they form neighbors already. So let's confirm that. When router 1, so IP route, associated routes on this routing table. Okay, inter area. See this route 172.30.20.0, that's in area 20, so it shows inter area. Okay, 172.30.10, that's another inter area. Okay, I'm going to show IP OSPF neighbor. You can see that we form two neighbors with router 2 and router 3. You can see the state is full, and router 2 is the backup designated router, and router 3 is the drawer, it's nothing. Okay, so backup designated router and the designated router, you are supposed to know that. Okay, the designated router is there to receive the information, hello messages, and all the update messages, and the backup designated router also is there for that purpose. Okay, so you just the purpose of backup and designated router is to manage the amount of information that is being sent to neighbors. Okay, so I'm going to router 2, okay, router 3. Let's check the topology. Now I'm going to redistribute this as the something says, as the objective says. We have to redistribute resource stated routes into the OSPF network from router 1. Okay, how is that done? Let me clear this. How is that done? First, I have to go to the router OSPF 1. Okay, summary address. I think no, redistribute. Sorry, thinking of redistribute command. Okay, type redistribute, and the question mark is very handy here. Redistribute OSPF process run. We are supposed to redistribute static here. So let's see. Okay, static. So redistribute static subnets. Okay, metric type, it should be metric type 2, metric 200. Okay, that's all we need to distribute those data graphs into the OSPF network. Okay, so now which static graphs? Do we configure the static graphs? Yes, I configure the static graphs already too. So IP route, you should see the static graphs here. So I will, from here I'm going to route 203 and type IP route, then I should be seeing all those static routes should be redistributed. Okay, so you see all the SS is in static routes. Okay, I'm going to router, let's see, router 3. So IP route, you can see type E2, the metric will always be 200. If bypassing 10, 20, 500 routers, the metric will always be 200. It's never going to exceed 200 because it's type 2. Okay, so good. Now let's go into router 4 here and enable the routing protocol. So IP protocol, no routing protocol there, so I'm going to go straight and configure the routing protocol. Router OSPF 1, router ID 4.4.4.4. okay, and network 172.30. Let's see, the topology is going to be 30.10.10.4. okay, it's the specific, and the area is going to be area 10. okay, remember I have loopbacks here configured, so I'm going to enable those loopbacks also. I'm going to inject those loopbacks into the OSPF top network. Okay, it is 10.10.10 10.0.0 0.0 55 area. Okay, let me cross check before. Yes, that is it, area 10. okay, by now we should, router 1 should be seeing those routers, those loopbacks. Let's see, so IP route, you see, those are the loopback interfaces on router 4. okay, dot 0, dot 1, dot 2, dot 3. yes, and going back to router 5, we go to router 5 and configure, enable the OSPF on router 5. okay, global configuration mode, I go to router OSPF 1, router ID, always configure router ID first, 1 2 3 4 okay, network 172.30.20.5 area 20. them an error. Okay, yes, and this also have some loopbacks. So I have some loopback interfaces 10.20.0. Okay, so 10.20.0.0.255 area 20. Cool. So I guess now let me show IP OSPF neighbors. Does it form any neighbor? It doesn't. So IP interface brief. Have I configured anything on the interface? 000, yes. 1032. Oh, look at that! Look at that! There's the mistake. There's the mistake. It should be 20, not instead of 2. So I'm gonna go and correct that. Interface serial 0/0. No IP address. Then IP address 172.40.20.5 255.255.255.0. Okay, enable should be forming now. Okay, you see it forms enable with the router 3 already. So I say so IP OSPF enable. See that this is point to point, so the state is full, but there is no GR or BDR election, in the point to point. So now I'm gonna see the routing table. Let me see the routing table here. So IP route. This router should be seeing all the networks, all the routes in this network, and even the external routes. So this is it. I should be able to ping those. I should be able to ping the loopbacks on router 5 from router 4. Ooh. 1021. Oh, yeah, 1021 1 or 1022.1 instead of, I don't have this IP address here, so it's going to be 1021.1. Yes, that should go. That should go. Yep, success, 100%. Good. So let's go to our next objective and see what is the other challenge question. So question number 2. After completing the initial step of the lab, one of the routers in area 0 will become the DR and one will become the BDR for the Ethernet segment. Which router will become the DR and the BDR? Write DR, BDR next to the respective router below. Okay, so the Ethernet segment here, that's the Ethernet segment. Okay, this is the network. So router 1, 2, 3. Let's see which router is the BDR and the DR. So how will I know that? So IP OSPF interface, I will know from that. Also there is another command also, so I can see that the fast Ethernet 0/0 is up, line protocol is up, internet address 172// area 0, which is router, the process ID, router ID. Okay, the state is DR. This is the designated router. It has a priority of 1. Okay, now say so IP OSPF neighbor. So IP OSPF neighbors, I will be able to see from here which is the backup designated router. backup designated router is router 2. We have router 2 as the backup designated router and router 1 as the designated router. So what is router 3? Router 3 is Drudder. That means it is not a backup designated router, it is not a designated router, it is other, or it's nothing. Okay, so that is fulfilled. Let's go to the third question. And so router 1 becomes the designated router on the Ethernet segment in area 0. Router 2 and router 3 should not become a designated router or backup designated router for the Ethernet segment in area 0. After this change is made, what type of neighbor relationship should exist between router 1 and 2? What about 2 and 3? Good. So what it is saying is, as we saw on the previous configs, we see that this router is the designated router and 2 is the backup designated router. But now the question is telling us to configure router 1 as the designated router, and the router 2 and 3 should not be designated router, neither backup designated router. So how are we gonna do that? We're gonna accomplish that by using the router priority. Okay, the OSPF router priority. We go to router 1, and router 1 is connected to the Ethernet segment with which interface? This is the interface, the fast Ethernet 00. Okay, so I'm going into the fast Ethernet interface fast Ethernet 0/0, and I say IP OSPF priority. I'm gonna give it like 200 here. Okay, exit and save and save. When router 2, and I go into the interface fast Ethernet 0/0 IP OSPF priority. How do we accomplish that? How do we configure a router not to participate in the election process, not to be a DR or BDR? We just give a priority of 0. With a priority of 0, the router will not be anything, will be Drudder. Okay, so router 3 interface fast Ethernet 0/0 IP OSPF priority 0. Good. So let's confirm it. So IP OSPF enable, we see that when we implement that command on router 2, we see the neighbors. Enables router 1, we see router 3, and router 4 enables. Remember, router 4 is in the point-to-point network, so there is nothing like Drudder PR concept on that. So but router 3 is a two-way. It's a two-way, and it's Drudder. It's not a designated, neither a backup designated. It's Drudder, and the state is two-way. Okay, and router 1, the neighbor relationship is full, and router 1 is still the designated router. So I'm going to router 3, and so IP OSPF enable. I can see that router 3, the relationship between router 3 and 2 is two-way. Okay, and router 3 is still nothing. So IP OSPF interface. Okay, it is Drudder. It is neither BDR nor DR. Okay, that objective is accomplished, and so router 1 becomes the DR on this interface. Okay, so they said what are 2 and 3? They are Drudder. Okay, router 4. Question 4. implement summarization at the ABRs in the network to make the routing tables throughout the network as efficient as possible. Optimizing the routing table using summarization. These are the ABR, router 2 and router 3. How are the ABRs? Because they lie between two areas. Okay, here also they lie between two areas. So you see that router 4 will be pumping those loopbacks, those networks, to router 2, and router 2 inject into the Ethernet network, all those routers. So in order to avoid all those traffic, we just implement summarization here on this boundary, then the network will be optimized. You see the difference between OSPF and EIGRP. On EIGRP, you can implement the summarization on any route, at any corner, anywhere inside the network, at the middle, at the center, wherever. So for OSPF, that is not the case. You have to do the summarization on the ABR, okay, or the ASBR. So we are going to summarize these networks. We're going to summarize this network. That's our summarization knowledge on CCNA. Okay, the system I use here, we have four networks, four IP addresses. So these four IP addresses, we're gonna summarize all this. We can see that the 10.10.0.1, 10.10.1.1. so what I will do is by using the increments, okay, 128, 64, 32, 16, 8, 4, 2, 1. Okay, these are the increments. 1, 2, 3, 4, 5. Good. So I see that the network, the summarized network will be 10.10.0.0. okay, because if you, so the last one you see 10.10.3.255. good. This is like the broadcast, so it's out of it. So but it's like from here, this is going to be 10.10.4.0. From this broadcast, we come to the next network will be 4. Okay, the next network will be 10.10.40. So but that is not included here, so we only have to from 0 network to the 3rd network, to the 3 network. So see the 4 here. Using those increments, we're going to count how many bits we need to come to the 4 here. So say 1, 2, 3, 4, 5, 6. So it's like 6 bits. Now we need 6 bits in this 3rd octet, okay, to get our subnet mask. Okay, see that here the 1st octet, the 2nd octet is all the same. So the 1st octet, 2nd octet will all be 255, 255. Okay, so the 3rd octet we need 6 bits on the 3rd octet. So 6 bits plus this is 255, this is 255. Okay, so it's like it's 8 bit here, 8 bit here. We know that 8 bit is 225. We all know that. So if you add the 8 bits to 8 times 2, that is 16, plus 6, that's going to be 22. Okay, so we have like how many bits? 22 bits. We have 22 bits. So the subnet mask of the summarized network will be cyber 22. Okay, so this will be 0. So the summarized network will be 10.10. The summarized will be 10.10.0. 16.0//22. Good. So I come to router 2, go to router OSPF 1, area, that was area 10. Let's confirm it. This is area 10. So area 10, range 10.10.0.0. Okay, and the subnet mask this last 22, 255, the 16, 252.0. Okay, so that's it. That is our summarized network. And we go to router 3. Router 3 is the same thing. Okay, the first octet is the same, the second octet is the same, the third octet we will need 6 bits to get our subnet mask, 6 bits on the third octet. So we have 8 bits here that are the same, the first octet, 8 bits on the second octet, plus 8, 16, and 6 bits on the third octet, that's going to be 22. So /22 on router 3. So on router 3, my laptop is hot, because the CPU usage is too much. Okay, guys, okay, go into the global configuration mode and go into the router OSPF 1, area 20, range 10.20.00.255.255.252.0. Okay, summarization implemented. Guys, you gotta forgive me, I cannot shout a lot. I guess you are hearing me well. Okay, yeah, summarization is implemented on these two ABRs. Okay, implement summarization at the ABRs in the network to make the routing tables throughout the network as efficient as possible. Let us cross check that. We go to router 1 and see its routing table. So IP route, we should be seeing the summarized routes of those loopbacks from router 2 and 3. Good. /22 10.10.0.0/22 is a summary address of those loopbacks from router 2, and this is the other one from router 3. So the routing table is now optimized. It's going to use less bandwidth. Okay, implement summarization at the ASBR. The summary route should have the same attributes as the original individual routes redistributed into the network. Now the summarization should be on the ASBR. And which one is the ASBR here? It is router 1, because it is the one that sits between our network and the outer world. So it is the last router to the in our domain is the router that is our gateway, I can say. Okay, after this router you either meet, I don't know, different routing protocol, or it's a totally different network which is not under our domain. So we're gonna summarize these static routes. We cannot just inject all these individual routes here. As you can see, if I go to router 2, I will be seeing the individual routes, and it is not efficient. So IP route, see 16.0, 16.1, 16.2, 16.3. Good. That is not optimized. We could have just summarized it and get only one route. So the summary route is going to be similar to the loopbacks here. You see that the first octet is the same, the second octet are all the same, the third octet is where the difference lies. Okay, we have 0, 1, 2, 3. So the next network will be 4. The next network will be 172.16.4.0, and which we don't need actually, but we need it to determine our subnet mask, the subnet mask to the summarized network. Okay, and the 4. So we do the increment here, just as I did here: 128, 68, 64, 32, 16, 8, 4, 2, 1. Okay, this 4 is the next network after the third network here. So what do? I just count as bits. Okay, I just convert all this as bits: 1 bit, 1 bit, 1 bit. So if this is like how many bits? 1, 2, 3, 4, 5, 6 bits to get to the fourth network, 6 bits. So I will need 6 bits in the third octet, okay, added to the 2 octets here, and get our subnet mask. So it's gonna be 8 bits, 8 bits, 16 plus 6 is going to 22. So I'm going to router 1, global configuration mode, router OSPF 1, summary address. The summary address is 172.16.0.0, and the slider, that's the summary mask, will be 255.255.252.0, and that's it. So it's been summarized, and it is going to get this. It's going to inherit the same attributes as the original. Let's go to router 3 and confirm that. So IP route, we should be seeing only the summarized route from the static route, and the metric should be 200. Okay, let's see. You see it here? You see this? You see this? One 172.16.0.0.0. This one /22 is subnetted, one subnet, and it is here A2, and the metric is 200. It will never change. I'm going to check it on router 5. So IP route, so you can see it here too, 200. No metric changes. Good. What is our next objective? 5. Implement summarization at the ASBR summarization. Okay, we're done with 5. We now go into 6. The organization plans to upgrade to gigabit Ethernet in the coming months. OSPF should accurately calculate its metric, assuming gigabit Ethernet will be the fastest link in the network. Okay, now this has to do with the cost. We have to know the cost. The gigabit Ethernet, 10 gigabit Ethernet, whatever is 10 is gonna be, the cost is 1. But now how do we tweak this? The organization plans to upgrade to gigabit Ethernet in the coming months. OSPF should accurately calculate its metric, assuming gigabit Ethernet will be the fastest link in the network. Look at here. This configuration have to be done on all the routers. They have to merge. Okay, the cost have to match here. So we are like predicting, we are doing a configuration. In the next few months we will be upgrading to use fast links. So we want to make sure that our network is fast. We want to make sure that all the routers have appropriate and similar, if not the same, configuration. Okay, how do we do that? We start with router 1. Okay, go to global configuration mode. Okay, we say router OSPF 1, outer cost reference bandwidth. Okay, now we choose what the question tells us. Gigabit Ethernet metric, assuming gigabit Ethernet will be faster. That's 1000. Gigabit Ethernet is equal to 1000. So I should put 1000 here. 1000 megabits per second is 1 gigabit. So good. So I will copy this. The cost of bandwidth. See, OSPF reference bandwidth is changed. Please ensure reference bandwidth is consistent across all routers. Okay, I'm going to router 1. Go to the router OSPF 1, and I will paste that. Okay, I'm going to router 2, global configuration mode, OSPF 1, and change the bandwidth, the cost. Okay, config terminal, router OSPF 1, and paste router 4, which is the last one, and router OSPF 1, and outer cost reference. The Spanish people will say outer cost. Outer cost reference bandwidth 1000. That's the gigabit. Cool. I'm gonna exit. That's right. So it's like saving. Exit, right. Exit, right. I'm saving our configuration. If you want to write copy, run, start. Yeah, copy, run, start. I just like writing right. It's hard. Okay. I think that is the end of the objectives. This is basically, it entails a lot of stuff that you will need to know in order to pass your CCNP route exams on the on the OSPF part. You can see that we talk about a lot of concepts. We talk about the core OSPF configuration, the route summarization, or the DR election process, and the OSPF cost calculation. So that is it for now, and watch out for the next video if you enjoy this one. Thank you so much.